Hi, my name is Dinesh Thakur. I am a research staff at the GRASP Lab and I work with Dr. Vijay Kumar. Today I'm going to show you multiple robots forming in different shapes in the air and coordinating with each other and not hitting each other. The robot that we are showing in the demo, it's a research platform. It was developed in-house. It's a around 250 gram micro aerial vehicle. We call it micro, which are like lower than 500 grams. There's bigger robots which fly also we have in the lab, but this ones we categorize them as micro scale. It's a quad rotor, so it has 4 rotors and motors, and then so it's used to fly. The cost of such a research platform currently would be at around $1,000 to $2,000. Given that it's a research platform, it's slightly higher, but once you commercialize it, we have seen commercial drone in this size and form factor around $500. If you have seen drone shows out in outdoors, most of them rely on GPS. So here we do not use GPS, neither do we use motion capture system. All of these drones rely solely on the onboard cameras and the processor, which is a cell phone grade processor equivalent to a Samsung Galaxy S5. So running single MAV or robot itself is challenging, and right now with this project what we are trying to show is a single operator can run multiple of this. You don't need like one operator per robot. In India, the schooling system is slightly different. So around high school time, you have to kind of choose what subjects you focus on. If you want to do engineering and medicine are the two main prominent areas that people, at least the parents, push their kids towards. So based on that, you have basically two options. You either focus on the engineering or maths and science courses or the biology courses. And I was leaning towards engineering because I used to try to tinker around with toys and stuff and other engineering tools. That's when roughly it was okay, I'll just focus on the engineering side of it and try to get in engineering. So we spin the propellers first, or the blades first. So once everything looks good, I'm going to send them up in the air. And we send them slightly higher so that each of these can see the tag and we kind of know roughly they are. Again, I'm going to go back and see if each of these have seen the tags and make sure nothing is wrong. We call it April tag. You can think of April tag as a barcode where it's unique, and it can, if you see that barcode or April tag, you can tell where the robot is with respect to that tag. So if each robot knows where they are with respect to tag, and if they communicate with the other robots, they know where the other robots are with respect to each other. And that way it helps them have a reference with respect to each other and helps with the formation to make different kinds of patterns in air or shapes in air. Arrange them in a circle with the center being the tag again. We can move the center of the circle forward and backwards or any other place with respect to the tag. Again, we are sending them in the line. So all the processing is done on the robot. All I'm telling is to form these different shapes in the air. Here I tell them to make a circle. As you can see, so the center of the circle is in the tag. And you can say to move the circle center and forward, you can say move it backward. My uncle was more kind of a mentor that way. So he always made us do things like just push the boundaries and try to do different things and not just focus on one thing. The battery life of these robots is roughly 7 to 10 minutes. We can definitely add a bigger battery and get a better flight time. This is a research platform, so we haven't optimized the weight of the robot to get a longer battery life, but commercial robots like this, which you can buy off the shelf, can run up to 30 minutes. Since we use this for research and development, we haven't spent enough efforts on trying to optimize the battery life, runtime of the robot. Micro aerial vehicles or aerial vehicles in general have shown great potential in first response, in search and rescue, and aerial surveys, photography in general. So what you can do with one robot now, if you have multiple robots, it increases with the area that you can cover. There is more resilience to failures with multiple robots. Other applications you can think of, multiple robots allows for nicer photography. Now imagine if you are shooting a movie or video or general photography, you can have multiple different angles and viewpoints, and you can dynamically change them and look at the same object from these different views. So that's a huge current application. Further applications can be inspections of dams and buildings can be done pretty easily. So imagine the small robot going in tight spaces. So you can think of first response or search and rescue, sending them in damaged buildings after earthquakes or some disaster scenario is one application. My father is an engineer, so that kind of I got interested early on, but in school, it was at a later point I started getting more hands-on doing science projects in school. For younger elementary school students to explore something in engineering, definitely I think at the high school or school level, the science fair is something which got me interested in partly, and then just joining different activities around in school which are more geared towards engineering would be one way. For me, in certain areas in design was art, so it's not just always science and math, I believe personally. There's other areas which can come in to help you down the line. Another application that we have been working in a lab is trying to see Wi-Fi signal strength. As you know, all of you would know how Wi-Fi signal drops or is choppy around different buildings or even in your rooms. So one project with Comcast that we are doing is try to see how to map the Wi-Fi signal strength. So imagine two robots going around a room, and we can test the Wi-Fi connectivity between two robots, and this will help the designers place the routers in exact locations so as to improve the overall Wi-Fi performance. Getting over a little bit of intimidation, I think initially just like reading and learning more, self-learning was something I did more. So anything that I didn't know, I would just spend more and more time trying to understand it by myself. And once I got a grasp of that area or expertise, then I would be less intimidated about doing more research. Research is very open-ended, and you don't really know where things are going to lead to, so you just have to find answers for yourself in general.